Hello guys, welcome to our class for today. This is Nobleman Science Tutors Online and I remain Otobo Michael. Today we are going to talk about relative motion. In our last class we talked about motion and the different types of motion. So for this particular class we'll be talking about relative motion. But before we continue, please if you are not subscribed, please subscribe to this channel and click on the notification button. Also for our returning subscribers, you can click on the thumbs up, give us a thumbs up so that you can encourage us. Then if you are new here, please subscribe to this channel. We are bringing physics class to your very doorstep, so please get your writing materials ready as we go straight to our class. So relative motion, that is what we are discussing in our class for today. What is relative motion? If you have traveled in a car, sometimes you will observe that if you are looking outside and the vehicle that you are traveling in is in motion, most of us have experienced it. You will see that the trees that are on the road, it will appear to you as if they are moving. They are not actually moving. What is happening is that because you are in motion, you are in a car, those trees they appear to be moving, and that is your motion is relative to the position of those trees. So that is an example of relative motion. That's an example of relative motion. So relative motion is the motion of a moving body or of an object in relation to a static object or another moving body. Right? So if you are in a moving train or you are in a car, just as I said before, you will observe that those static trees that are outside, they will appear to you as if they are moving. That is relative motion. Okay, that is relative motion. So a car traveling on the road is in a relative motion with respect to the poles and trees that are on the road. So that experience you have of those trees that are standing outside that are moving, it is because your car or you that is in the car, you are in relative motion to those trees. Also, any other car that is passing you, you are also in relative motion to those other vehicles that are moving. So the occupants of the car, they are also in relative motion with respect to the poles. Also, the car is in relative motion with respect to another moving vehicle. So basically, that is what relative motion is. Your motion relative to the motion of other moving objects or relative to other static object outside. That is what is called, or that is what is described as relative motion. So this is just like an example I want to give to you so I see what relative motion is. Okay, so that is relative motion. That is demonstration of relative motion. You see the blue car and the red car, they passed each other. So their motion is relative. The motion of the occupants in each of these cars, they are relative to each other. And then these two cars too, they also pass this rigid building that is here. So their motion is also relative to this static building that is not moving. So that is basically what relative motion is. And that is what I've demonstrated here. So that relative motion, and we are going to go straight to some calculations that has to do with relative motion. Okay, so this is an example. This is an example. This is actually a past wire question. So two cars S and Y traveling in opposite direction along the same path at uniform velocities 200 kilometers per hour and 50 kilometers per hour respectively pass each other at a certain point. Find the velocity of x relative to y at the time they pass each other. Find the velocity of x relative to y at the time they pass each other. Now, for relative motion, This is the formula for the calculation of relative motion. If the car that is moving forward, or let me say if you take from your left to your right as forward direction, then from your right to your left will be opposite direction. So you have forward velocity minus plus or minus depending on the direction of the other car. If the other car is moving opposite to the direction of the first car, then it will be negative velocity. So this place will now be negative. But if the other vehicle, if the two cars are moving in the same direction and maybe one overtakes the other, then the sign here will not be positive because they are moving in the same direction. This sign will be positive. So it will be forward velocity minus plus is minus. But if it is in the reverse, minus minus is plus. So that is just the formula for calculation of relative velocity. This formula, please take note of it, because from review of past questions, I've discovered that they always bring questions on relative velocity, and sometimes students find it difficult to calculate. So this is the formula for calculation of relative velocity. So in this particular case, if you put this formula and bring down these values that are given to you, you see the velocity of the first car is 200 kilometers per hour. 200 kilometers per hour. And then the velocity of the other car is 50 kilometers per hour. And because the other car is moving in opposite direction, it will be minus 50 kilometers per hour. So questions on this are always very simple. So what you have here will now be plus. So you have 200 plus 50. Okay, so that gives you 200 plus 50, so that gives you 250. Okay, so 250 kilometers per hour. So which means that the velocity of x related to that of y at the time they pass each other will be 250 kilometers per hour. 250 kilometers, because the other vehicle is traveling in opposite direction. Now assuming they are moving in the same direction. If they are moving in the same direction, then the velocity will just be this, to be 200 kilometers per hour minus plus, to be plus since they are moving in the same direction, plus 50 kilometers per hour. Okay, so that gives us 200, give us 200 minus 50, and that will now give you 200 minus 50 is 150. So that gives you 150 kilometers per hour. Okay, this is if they are traveling in the same direction. But since the question says they are traveling in opposite direction, this is what you will have, 250 kilometers per hour. Use this formula, you will get this, and this will be negative sign. But if they are going in the same direction, this will be positive. So this is what you have, 150 kilometers. At the time they pass each other, this will be their relative velocity if they are moving in the same direction. But if they are moving in opposite direction, this will be their relative velocity. Is that okay? So I believe this is relatively simple if you can follow the simple example. Alright, so we'll go straight now to your test page, but before then, this is what I was basically talking about. Okay, so since the car they were moving, one is moving opposite to the other, the relative velocity will have a minus sign on the second uh, value. So I have a minus, and that gives you 250 kilometers per hour. But if they were traveling in the same direction, then this is what you will have. You have 150 kilometers per hour as their relative velocity as at when they pass each other. All right, so thank you so much. We are going straight to your test page. Okay, so this is test your understanding. I want you to go through these questions. This is a wire question, and this is a jam question 2010. So this one, the driver of a car moving uniform speed 40 meters per second observe a truck approaching in the opposite direction with a speed of this. Calculate the speed of the car relative to that of the truck. Okay, so just follow the example that I gave and then go and check some past questions. These questions are always reoccurring almost every year. Check your past questions for JAM, your WAEC, your NECO GC, your NAPTEP. You will see questions like this. You see questions like this. So try your hands on them. Try your hands on them, because in physics, the more problems you solve, the more you will be thoroughly grounded in all the topics. There's no topic that does not involve calculation. So you have to be ready to do a whole lot of calculations in physics, right? So thank you very much. Try your hands. Put your answers on the comment section below, or there's a WhatsApp link that I will also display. You can put your answer, click on the link, it will take you to the WhatsApp page, and then you can put your answers there too. I will also check them and make my comments. I think I will also put my WhatsApp number on these videos so that you can put your you can add me up, and then we can communicate on WhatsApp. Is that all right? So thanks a lot for your time. If you have not subscribed to this channel, please subscribe, and then click on the notification button, and whenever we upload a new video, YouTube will notify you. Also, please invite your friends. If you like what we're doing, give us a thumbs up. Give us a thumbs up to encourage us. Then invite your friends to come and enjoy this physics class on YouTube. So we're going to see you in our next class. Thank you.